we want to get a classroom climate in our schools so that promotes students thinking and engaging in the work. We want to build a mathematical community of learners so that all of us can learn, not just the students that we're teaching, but we can learn as well. So this is really interesting because I know something you don't know. Okay, well, all right. I know a couple of things that you don't know. One is that I do know what the answer is. But even more importantly right now, I know what your answers are. And I know that some of your answers don't agree.
And I'm going to piggyback on that. And what you also did was said, this is how we solve this problem. Meaning there is no other way that I could solve condominium problems. I solve it that way because that's the way you showed me. And you're the teacher, so I'm supposed to follow your direction.
You're supposed to do what I say, right?
And the way that I said.
It was what?
It was like a script.
It was very much like a script.
Very scripted.
Or an algorithm.
Yeah, it's almost like, how many fingers am I holding up? How many? How many?
And then I say 2.
Right.
And then the next one, you give me
Okay.
a.
Anything else to add at table 2? Any other differences?
I think you just led us, like they said, you gave us the direction, so we were not able to kind of discover different ways of doing the problem.
Or struggle with it.
Say that again.
Or struggle with it.
Or struggle. So there's something that's really really necessary, I think, not just for students but for adults as well, and that's that productive struggle. Sometimes we need, because we're getting students in this class who, for some reason, haven't made sense of some of this other stuff. And my reason for giving you this problem was to put you in that position, to make you feel like sometimes our students feel. Anybody ever have a student who, just kind of raise your hand because I know they're going to go up, who reads a problem and immediately starts trying to add, subtract, multiply, divide, something, those problems? Anybody? Anybody? Yeah, I thought so. Okay. We have to train our students to think and make sense. I don't like to be the answer key. So nobody's given me the power to do this yet, but I'm doing it for you guys anyway. I'm absolving you of all of the answer keyness that you have to have in your classroom. You don't have to be the answer key.
Not obligated to be that.
And I know I just make up words. You're not the answer key anymore. Your students need to become the answer key.
What I was going to say is it's funny because we've been talking, I think, this entire time about how we go to procedural. So we were so quick to try to work through formulas. And I think what we're trying to move into is to having children like be able to explain what they're doing, why they should do it a certain way. And so models help you come to that as opposed to just knowing a formula to plug into.
Or you can simply say, as long as you can justify your response, then I will accept it if it's a reasonable justification. And then that gets them into the practice of defending their answer and their arguments in that tone or knowing that language, because they're going to have to do constructed responses, which is about justification.
Knowledge is not understanding, right? We need to keep in mind that just because we say something to kids and we want them to remember it doesn't mean they understand it. They have to build their own understanding through concrete, representational to abstract. That's making sense of the problem. Right? Exactly. The context is driving us to have this debate about math, and that's what we really need. Kids need to have those conversations. It's not about me telling you, oh, 10 and a half is fine. Oh, 11's fine. It's about making sense and really deciding which one makes sense in this context. Did you see that? Do that again. No, because we've been doing air fives all day, and yeah. So that's the goal in math class. Get your kids to high five.